All right, welcome everybody. Let's do this. So this is going to be part 3. The first part we had was lesson 14, and the first page looked something like this with the roller coaster, and we did all that. Your next page, this was part 2 over here, and part 3 will look just like this, okay? And if you're thinking, oh man, Mr. G, these are so many things we need to do, it's not as bad as it looks. But if we were to understand all these concepts, you're really going to understand the concepts of graphing and what they mean. So let's look at the first part. If this is our function f of x, right? X times x minus 1 times x plus 1. Let's look at the first part. It just says graph the polynomial. Okay, so we could do that. If I wanted to graph this polynomial, just go y equals, let's just plug this in. So x parentheses x minus 1 times x plus 1. Okay, so we graph this, and what does it look like? Bam. So we know that here, notice it hits at -1 and it hits at 1. And you know what I want to do? Maybe I want to make my window a little bit better. Let's make my x min 5. Let's make this 5. Let's make this, oh, this should be, delete. This should be 5 over here, delete. I'm sorry, -5 and 5, and if we hit graph, it looks a little nicer, right? Okay, so then this should be our graph. So all we need to do is, let's just graph this over here. If this is my y-axis, and then here this is my x-axis, and then bam, let's make this 1, right? And let's make this -1, okay? And then how should our graph look like? It'll go up, it'll start down from here, it hits -1, then it goes back down, it crosses the origin, right at the center, it goes down, and then it goes straight up. And this is our graph over here. Congratulations. Let's look at the next part. What are the function zeros counting multiplicities? So we know that here, what are the zeros? So if I were to have like answer choice 2 here, right? If I have x times x minus 1 times x plus 1, it's pretty straightforward. What are my zeros? We know the first 0 is 0. We know the next 0, if x minus 1 equals 0. And then what are we going to do next? We're going to do x plus 1 equals 0. So we just know that the zeros are x equals 0, x equals 1, x equals minus 1. Okay? So we're done with part 2. Let's look at part 3. It says, what are the solutions to f of x equals 0? Well, okay, I guess 2 and 3 are kind of the same thing. They're just this, okay? And here it says counting multiplicities. Let's ignore that for now. What are the x-intercepts of the graph? Well, here, if I know these have to be the x-intercepts, but here, what are the actual points? This point here is -1, 0. That's a point. What's this point here? It's 0, 0. And what's this point here? It's 1, 0. Okay? So far, so good. Let's look at 5. How does the degree of the polynomial compare to the x-intercepts of the graph of the function? So let's just look at it from one part. So what does it mean to be degree of a polynomial? Degree of the polynomial is if I were to multiply this whole entire thing, like here, if I have x times x times x, the highest exponent eventually will be 3. So the degree is 3. And notice that if I have degree 3, how many intercepts do I have? I have 3 intercepts. 3 x-intercepts. Okay? And this doesn't mean that if the degree is 3, it has to have 3 intercepts. It means that at most, they could have 3 intercepts, but we'll talk about that soon. Let's look at number 6. It says, what are the relative maximas of the function? Well, the relative maximas are going to be where the function goes at its highest peak. This is going to be a relative maxima right here in this. Okay, maybe I should do it in a different color. Let's do it in the pink. This will be my relative maxima. Let's look at 7. What's my relative minimum? It'll be this point over here. It's that point here. So how can we find, here I'll zoom in a little bit. here, how can I find this maxima, right? This relative maxima. We're on number 6 right now. Well, all I need to do is go to my function over here. Let's go to my graph. And the first thing I'm going to do is I'll hit second, right? Trace. And now I have this command. And I want to go to maximum. So if I hit maximum, and now if I hit, let me zoom out a little bit. Sorry. Okay. Camera angle is good. Okay. Now I'm going to hit enter. And notice that it says left bound, right? So here I'm going to go left. And I'm going to go very close to that point over here. And now I'm going to hit enter. And now it says right bound. So now I'm going to go a little bit to my right. And then now I'm going to hit enter again. And now it should say guess. And if I hit enter again, it's going to give me the point. And my maxima is negative 0.577 and 0.384. So then this is the point. It's going to be, let's write it here. This point here is negative 0.57, comma, 0.38. That's a point, and it's right over here. Okay? Find the minimum. How would I find this minimum point? Well, you know, same idea. What I'm going to do is I go second, trace, and instead of maximum, I just go to minimum. I hit enter, and I go to my left bound, which is under here. Left bound, enter. Right bound, I go very close, enter. And notice that it's going to try and guess the point over there. I hit enter, and bam, there's my minimum. It's going to be, so this is for 7. Let's look at it here. For 7, this point over here, I'll put it in the green arrow over here. This is 0.57, right? That's my x value. And what's my y value? It's negative 0.38. Okay, and notice that there's some sort of symmetry going on, right? This is negative, this is positive, this is positive, this is negative. Okay, and now here, this part, 8 and 9, will take a little bit of work. Okay, so what I'm going to do is I'm going to pause the video real quick, and I'm going to show 8 and 9 on another piece of paper. Seemed okay. 8 and 9 will be the very difficult part. So it's saying for 8, which interval is x increasing, and for 9, when is x decreasing? Okay, so let's take a look at this. If I have this graph here, right? It's the same graph we have here. I just extended it so it looks over here. When is x increasing? Notice that if a graph goes, you see, from left to right, that's how we read a graph. If I look left to right, this is decreasing. Okay? When I go left to right and it's going down, this is decreasing. But when I go left to right and it's like this, we say it's increasing. So if I take a look at this, let the pink be decreasing, right? This will be decreasing. When is the graph decreasing? And the graph will be decreasing from here to here, right? Because this is from left to right, my graph is decreasing. And notice that it's from this maximum to this minimum. When is my graph increasing from left to right? Let's have it in the green, and it will be this area here, okay? See here, if I look left to right, x is increasing, increasing, it hits the maxima, it decreases, it hits the minimum, then it increases, okay? So the question now is, how do I show this in interval notation? The idea is pretty straightforward. So how do I show this green here? Notice that what is my x value over here? It's negative 0.57. So from x, when x is, what would this be? This is less than negative 0.57, but x has to be greater than, now where does this go? This is going to negative infinity. Okay? Between negative infinity and negative 0.57, x is increasing. Here, when is it also increasing? From x to 0.57, right? 0.57 on the right side, and it increases to positive infinity over here. Okay? When is my graph decreasing? Well, x has to be between the two relative maximums and relative minimums. So between 0.57 and negative 0.57, this is when it's decreasing. Okay? I hope this helped. I'll see you.